Hey friends, here is part 2 of your review. So in this case, we are going to go over non-experimental science. Hopefully we'll go over nice and slow, step by step, so you'll have a better idea of what it means by the end of this video. So to start off, non-experimental science is used for situations and the explanation of questions that we can't perform a controlled experiment on. For example, we can't perform controlled experiments on space, the stars and planets, or on people's memories or their brain function. So this is used a lot for psychology, economics, anthropology. Hopefully we'll do some more on psychology soon, but that is where I find most examples that are pretty straightforward. So first off, we use inductive reasoning. Now, inductive reasoning is saying, let's go to the egg example. A carton of eggs has 10 eggs, or not 10, 12 eggs, excuse me, and 11 are rotten. Therefore, we're going to assume that the 12th is rotten. Now, we can't tell because we can't, for sure, because we can't physically look at the eggs. We can't examine them. We won't truly know until we do that. But we can take in information to try to make a conclusion. So in this case, we need to take in information in order to make our conclusion. So we could do senses. We could smell the carton. We could smell the egg. We could look at the egg. We could see if it looks different. Maybe poke it, touch it, see if there are any differences from what we know is a normal egg. We can use detection. So that would be like using some sort of meter or, electronic equipment to detect if it is rotten. A good example of a detection is like a smoke detector. It detects if there is smoke. We could use some sort of indication. So that would be like something that will show you if a certain chemical or a certain item is present. I know sometimes people use pH paper in fish tanks to see if they'll change color to see if the pH is too high or low. That's an example. Or you can use intuition, which is just like your gut feeling. Your fight or flight response is an example of intuition. So that is our natural response to either run away or fight something that might negatively affect us. So these are just a couple of examples, but in other words, we're just trying to gather data. Now, two big examples of non-experimental science that we see are 1, studies, and 2, surveys. Now, a study could be just about anything. That could be you literally going out into the field and collecting these pieces of information. So maybe I go and observe some sort of animal in the wild because I believe it'll do a certain behavior. This could also include doing research studies. So looking into past information and seeing if you can find patterns and trends. Now, a survey would be something that you would give. So if you've ever done a questionnaire, I gave you a survey the very first week of school. It is an unbiased, which means that your questions are neutral. They're just to gain information. And it's just to, again, it's a way of collecting information in order to make sense out of it. So those are the two most common examples, and is what you'll see more often. Now we are going to go over our components of non-experimental science. So this is kind of like our variables and our different groups in experimental science. So in this case, we have the explanatory variable. Variable. We have our response variable. We have a lurking variable. or variables. This one's multiple. We have the associate and the cause. So for example, let's say that I want to study why people buy a certain brand of soap. One class came up with this when we were doing an example for a controlled experiment and a non-experimental science example. So you might, this might sound familiar, but it's a great example, so I'm going to use it. So our explanatory variable, that is what we are trying to explain. Essentially, this is in a way our independent variable if we're trying to relate it to a controlled experiment. Our explanatory variable, that's what we want to explain. So let's say we notice people are buying a certain brand of soap, and we want to see if buying that certain brand of soap is associated with longer hair. Let's say we think that, I should say shampoo instead of soap. So let's say that shampoo is related to longer hair. So we want to see if there's any connection. So our explanatory variable, what we're trying to explain, let's say that we notice people buying a certain brand of shampoo. We want to know if that certain brand of shampoo is associated with people having longer hair. In this case, our explanatory variable, what we want to explain is people buying the soap. So people buy soap. That's what we originally observed. That's what we're trying to explain. Do people buy this soap? Now, the response variable. So that is the response to our phenomenon. So, or our observation, like we mentioned in class. So we observed people buying a certain brand of soap or shampoo, and we want to know what the response is. So what is that? What is being caused by people buying soap? In this case, what's being caused would be the long hair. So is that certain soap causing people to have longer hair? If you noticed, our explanatory variable is very similar to our independent variable in controlled experiments, and our response variable is very similar to our dependent variable in controlled experience. If that helps you remember them, that's a great way to think of it as well. But we're going to go on to why this is so different, specifically into our lurking variables. So in a controlled experiment, we would be able to control everything. So we'd be able to control everything except that independent variable. We cannot control everything in non-experimental science because, it's a study. It's us gathering information, but we can't control all of our surroundings. So lurking variable is pretty much anything we cannot control. So this would be like age of people buying the product, maybe how much money they have or not, etc. So things that we cannot control. Now, associate, these two aren't variables. These are just words that we need to know the definition of. Associate means to be linked together. So one thing is influenced by the other. In this case, our response variable is associated with our explanatory variable because our response is affected by the explanatory. We'll talk about association and causation in class, hopefully. Now, causation means that one thing definitely happens, makes the other thing happen. So in this case, if we were to find that people do have much longer hair when they buy this soap, and we did a lot of research, maybe did some extra afterward, we could say one causes the other. But without more solid concrete proof, we can't necessarily say one thing causes the other because cause is definite. That is a definite, it's a definite outcome from a certain, act or phenomenon. Associate means they might be associated with each other, but there isn't necessarily a cause. So it might appear that people have longer hair because they buy this soap, but we don't know if that is the definite cause. We just know that they are associated with each other, more like a trend. All right, friends. We'll talk about this more in class. I know this is a little more confusing. But, I'll scroll out. So if you want to look at everything together, you may. And let me know if you have any questions. I will see you next week in class. Bye-bye.